In this video, we look at the classification of the elements and the different groups within the periodic table. We look at the periodic table, those different blocks of the periodic table usually involve the name, the symbol, and other information about the structure of the atom. So in this case here, we see it has the name and the symbol, has the atomic number, the atomic mass, and each of the electrons within the different energy levels of that atom. But some other common information is the state of matter, melting point, boiling point, density, ionization energy, and atomic radius, and then there's other ones that have even more information than that. The periodic table is broken up into different groups and periods, again the groups going vertically, or also known as families, and the periods that go left and right, and sometimes even called series. But some important groups within the periodic table are the first column, all the way to the left, group 1A, they're called the alkali metals, and then the next column to them from the left, 2 over from the left, is 2A, and they're the alkaline earth metals. Their name comes from the fact that you find them in ashes when you burn certain materials. These appear in the ashes of them. And also they make basic solutions. So you've probably heard basic solutions called alkaline or alkalinity. And again, that's because as the group 1A and group 2A metals are dissolved into solution, they make basic solutions because they can replace the hydrogen in water, leaving hydroxides, making that solution basic. Then the next important group is all the way to the other side of the periodic table, second to last one from the left or second from the right, and that's the halogens, and their name comes from being born from salts. Like you think sodium chloride, chlorine is in salt, but actually a salt is any ionic compound made up of a metal with a nonmetal, and all of those within the halogen group make really good salts because they are very reactive. And then lastly, the opposite of that are the noble gases, who are very inactive. You never find them in compounds. They're always going to be found in their elemental state, just as singular atoms. And again, they're called the inert gases because they're not very reactive. They're not very reactive because of their electron configuration. They have a very stable electron configuration, so they get their own, again, special group called the noble gases. And then we have the representative elements, transition metals, and intertransition metals, again, having to do with what the electron configurations are for these different elements within those larger groups in the periodic table. And that's because, again, these electrons play a really large role in what these different chemical properties are going to be for these different elements, especially, again, within these larger groups because of the number of valence electrons that they have, the way that those electrons are configured throughout that atom. And the electron configuration for the noble gases is what makes them not want to react, because they have this full s&p orbital in their highest level, with the exception of helium, who in that first ring fills up with only one s2, making that first ring filled and making it stable, just like everybody else in that family, all the way on down through the column. Again, having that full s&p orbital is what makes them stable, making them very reluctant to give up their electrons in the outermost level. So looking at helium, all the way down through neon, argon, krypton, xenon, and radon, that S and P in their outermost energy level is completely filled. Opposite the noble gases are the representative elements. They are very reactive because they have a partially filled S and P sublevel in their highest energy level, so they really badly want to either give up or take on electrons to be like a noble gas. So across the representative elements, we have a very wide range of chemical and physical properties, but within that group, it's very predictable what those properties are going to be, because there's very little difference between the top and the bottom of each group as far as what the chemical and physical properties are going to be. It's a very predictable pattern that occurs throughout them. And again, their number of valence electrons is going to be equal to their group number. So group 1A all has one valence electron, and 2A has 2 valence electrons, all the way across again to the halogens 7A with 7 valence electrons. So their group number represents how many valence electrons there are for each of those families within the representative elements. In the middle are transition elements. As you transition from one side to the other side of the representative elements, the group B elements, as the transition metals are called, are again in the middle of the periodic table, where it kind of sinks down a little bit, and they all fill into the D sublevel when doing out the electron configuration. They create a bridge as they connect the representative elements from the left side to the right side of the periodic table, connecting them again to each other. And then lastly are the inner transition elements, which are down below the periodic table. They fill into the F sublevel. They actually belong up inside the periodic table. You kind of split it between group 2A and the transition metals. They do fit nicely up inside there if you follow along the atomic numbers, but it would make the periodic table really long and not fit so well on a sheet of paper. Again, here we see the periodic table. If you were to do out the electron configurations, each one ends the same exact way within every single group or family, with the exception of helium up there that only ends 1s2, but everybody else ending p6 in the noble gas family. The representatives end s1 and s2 along, then you cut across p1, p2, p3, p4, p5, those tall columns, those are your representative ones. In the middle, the transition metals, again, they fill into the Ds, D1 through D10, and then lastly, the inner transition metals down the bottom, that yellow block down there, they fill into the F sublevel. Against these electron configurations that are going to create these repeating patterns within the periodic table because of how the electron configuration ends the same way for all the elements within each group and family.